Using generics in C# will help you to write clean and multipurposeful code. They are most commonly used in methods and classes, and using them, you don't need to specify the types of the input and output values. So when you want to create some method that will be working with multiple data types, you can use generics. Let's say that in your game you will have some collectibles, and for each of the collectibles you will need to create a class that will be holding two data values. But for each of the collectibles, these data types can be different. One collectible might have two strings, then you might have an integer and a float, and so on. So normally we would need to create many data classes. But you can see that creating this many classes with different data types would get messy really quickly. So how can we fix that? We can create one class that will be holding two generics data types, so that we can input any data type that we want. Normally, we would define the class like this, but when we want to use some generics, we need to type the angled brackets and into them some name for the type that we are going to use. So you can give it any name you want, but the standard is to use just T. And this is now representing the data type that we'll input when creating the class. So this is some data type, and I can use it when creating these two variables. So these two variables will be of data type T, which we'll specify when creating instance of the class. I have also created a constructor for this class so that we can easily create instance of it in start and assign the values. So I will create new data, then into the angled brackets we will need to specify the generic type that we want to use. So this can be, for example, integer, then give it some name, equals new data integer, and into the parentheses type the values, because I have added the constructor, so we can do that. And because both of the values need to be of type integer, I can type, for example, 0 and 2. And then if I would want to have another data class that would be containing two strings, I can do that pretty easily. Just like that. So we can already see how useful generics are, but I want to have two values and each one of them might have different data type. So right now, if I would input string here, so we have an integer and a string, it is not working because in the class we have defined just one generic type and both of the values have the same generic type. So what we can do is assign multiple generic types. So I can say t1 and t2. The first value will be of type t1 and the second one of type t2. And now, when creating instance of the data class, we don't only need to specify the first generic, but also the second. So I can say that the data will be containing value of type integer and string. Now you can see that it is working for two different data types, and like this we could add as many data types as we want. Obviously you don't have to be only using strings, float and integers, you can also input your own data types. So this is how to create a generic class, but on its own we are not able to do a lot of stuff with just a generic class. We can create also a generic method. What I will do is just to debug all of the values from the data class. Normally it would work just like that, but because the data class is containing two generic data types, we also need to put them to the definition of the method. So after name of the method to the angled brackets, we'll again need to define those generic data types. So for this method, we are defining two generic data types. I again called them t1 and t2, and then I'm using them in the parameters in the data class. Then I'm just debugging the two values of the data class, and in start I'm calling the method for both of these classes, and we just need to specify the types that we have in the data class, but you can see that the compiler is smart enough to understand what types we are feeding in, so we can actually delete this part. So now we can create data class which will be containing two data types, and we can make them anything we want and call the debug data method. And you can see that it successfully outputted those values that we wanted to get from the data class. Now let's say that in the debug data method, we also need to know which type these values are. And we can do that pretty simply by adding it to a if. So I will do if, and then we'll take the first value, so data value 1, and we'll ask if it is, for example, integer, and if it is, then we can debug that block and say that it is int, and so on. And yeah, we can see that it is correctly telling us that the first value is integer and then it is a string. Now, if the value is, for example, integer, we might want to do some math with it and so on. So you might be thinking that you can just do data value, for example, plus equals 10. But we are not able to do that. Instead, when we are checking if it is integer, we need to create a new variable and then we can modify that value. So like this, if the data value 1 is integer, it will add 10 to it and then debug that log as the value. Yep, that's working correctly. So now we are able to create a generic class that can contain any data types we want. We can also create generic method into which we can also input any data types we want. You could do the same thing with the output. So for example, private, then t, and then name of the method so that it can output literally anything. We also know how to check if data type of a value is something. And the last thing is the keyword where, which allows us to constrain the generic types. So for example, in the debug data method, we might want to constrain it so that it is only working with structs or classes. So we can just say where, then the generic type, for example t1, and we can use the colon to check if it is inheriting from something. So if it is a struct, so here you can see that it is giving us error because the string is of type class. So we can also make it inherit only from class. And now it will again not work because we have an integer which is inheriting from the struct. You can also constrain it to inherit from your custom classes or just from mono behavior, which is pretty useful. So now this method will take only mono behavior scripts and nothing else. So now you know how to create a generic class, how to create generic method, how to constrain the generic types to be only inheriting from some other classes, and how to check if the generic type is some type. Generics can be also used with interfaces and delegates, so feel free to experiment with it. The principle is still the same. I hope that this video was useful. If you have any questions, drop them down to the comments. Don't forget to like, subscribe, and I will see you in next videos. Bye! Thanks for watching this video till the end. If you are looking for a Unity, C# or Bolt tutor, then I am here for you, so feel free to send me a message to my Gmail and take a look at my website for more info. I can help you with your personal projects or teach you anything about game development you would want to know. You are welcome.